Another form of quadratics, or another form that they come in, is the intercept form, and we call it intercept form because if it's in this specific form, it actually gives us the x-intercepts of the equation. You just have to solve for them. So the picture there is of a parabola, and it's in this form: y equals a times x minus p times x minus q. So if you're looking at the equation and looking at the parabola, your x-intercepts are p and q in your equation. So if you take notice, it's x minus p and x minus q, but when you actually plot your x-intercepts on the graph, they're positive. That's because whatever number value is inside those parentheses, you guys would really have to solve for. So we don't know what p is, but if you set x minus p equal to 0 and you solved, x would be positive p. That's that first x-intercept there on the graph. So what always happens is it's always really just the opposite sign. It's in factored form is what it is. So it gives you those two x-intercepts, and then the vertex for these equations is in always the middle of your two x-intercepts. So say this x-intercept was 1 and this x-intercept was 5. What's in the middle of 1 and 5? Well, you guys could count, and it would be 3. I put too many dashes there. So you can physically look at it and find the middle, or what we do is plug it in. And that's what this over here on the left is telling you to do to find the vertex. So say it was 1 and 5. 1 plus 5 is 6. 6 divided by 2 is 3. So this axis of symmetry is in the middle. It's the average. That's really what you're finding, the middle, the average of those two x-intercepts. So once you find your x value of your vertex, then you just plug it in to your equation to find your y. And then you get your vertex. And then if you've got 3 points, guys, so that you would have that vertex, you can really just draw in the parabola. So let's look at an example. So example 3 wants us to graph the equation y equals negative x plus 1 times x minus 5. So what I do, even though it's not listed first, is I find the x-intercepts first. So in this case, technically, algebraically, you would set both of those factors, x plus 1 and x minus 5, equal to 0, and that leads you to your x-intercepts being negative 1 and positive 5. And we write intercepts, because they're points, as ordered pairs. So you guys can go ahead and plot those a while if you want. Negative 1, positive 5. So this is what I mean. You guys could physically look at the graph and see that the middle is 2. So that is where your axis of symmetry should be. But let's also find it algebraically. So if you're finding the vertex, let's find x first. So x equals negative 1 plus 5 over 2. So that would be 4 over 2, which is 2. So find x first, and then find y. So negative 2 plus 1 times 2 minus 5. So that negative in the front, guys, is really just a negative 1. So if you want to make that a negative 1, that is perfectly fine. So you have negative 1 times 3 times negative 3. So what is negative 1 times 3 times negative 3? Positive 9. So this vertex is 2, 9. So you guys can go ahead and plot that on your graph a while. And remember, if you know the concavity of your graph, it helps with knowing if you're plotting your points correctly. So yes, 9 is off the graph a little bit. But because of the negative a value, that negative in the front, I do know that my graph should open down. So it makes sense that my vertex is a maximum at that 2, 9 value. And then where is the axis of symmetry? Always through that x value of your vertex. So if you found the vertex, you know the axis of symmetry. Through that x value of 2. So that's it. When it's in X-Intercept form, you really find 2 X-Intercepts, plot them, then find your vertex, plot it.